Hey, mathematicians. Today we're going to be talking about the 9-4 compositions of transformations. So continuing to look at transformations, but this is going to be putting a couple of them together. So what we're going to do is start with the composition of transformations. So when a transformation is applied to a figure and then another one's applied. So a composition means we're doing more than one thing. Okay, it might be a reflection, then a glide, so it's going to be a couple different things in one. So the key concept here is a glide reflection, and it's the composition of a translation followed by a reflection. All right, so glide reflection, you translate, you reflect. You translate, you reflect, and so on. All right. Here's an example of a composition. So we have the quadrilateral BGTS there. We're going to graph its image after translating along the vector 5, 0 and reflecting in the x-axis. So we're going to do two things. So here we go. So if B, we're going to translate along 5, 0. So that means I'm shifting it 5 to the right and up 0. So 1, 2, 3, 4, 5. Here's B prime. G, 1, 2, 3, 4, 5. Here's my G prime. T, 1, 2, 3, 4, 5. That's going to be T prime, and S, 1, 2, 3, 4, 5. This is S prime. All right. Now what I need to do, here we go. We're going to reflect it along the x-axis. Let me make sure I get it all connected here. Not too bad. Okay, now we're going to reflect it along the x-axis. So when we reflect it along the x-axis, like if I look at T prime, it's 1 above, so now it goes 1 below. That's T double prime. G is 1, 2, 3 above, so it's going to be 1, 2, 3 below. That's G double prime. B is 1, 2, 3, 4 above. It's going to be 1, 2, 3, 4 below. That's B double prime. And then S is 2 above, so S double prime is going to be 2 below. So here's the graph of the composition. Right? You need to do it in the order that it says. That's also very important. Okay, so a composition of isometries. The composition of 2 or more isometries is an isometry. Okay, so isometry is basically we're taking the same thing and creating it. We're not changing its shape or size. Okay, so here we go. Let's go ahead and do this without graphing it. We're just going to talk through. We've got T, U, and V. So with this one, we're just going to take the point. So 2, -1, 5, -2, 3, -4. All right. So we're going to translate it along -1, 5. That means I'm going to subtract 1 from the x. I'm going to add 5 to the y. So T prime is going to be 1, 4. U prime is going to be 4, 3. And V prime is going to be 2, 1. All right. Now, we want to rotate it 100 degrees about the origin. And so with 100 degrees, the rule is you take opposite x, opposite y. All right, so opposite x, opposite y, opposite x, opposite y, opposite x, opposite y. So this is going to be the coordinates of the final image. All right. Now, here's where we want you to take a peek. I think the previous part is building on what we talked about. This is going to be brand new, reflections in a parallel line. All right. The composition of 2 reflections in parallel lines can be described by the translation vector that is perpendicular to the 2 lines and twice the distance between the 2 lines. So what does that mean? Okay. So we've got our 2 lines here. Okay. we have our distance between the two parallel lines. When we reflect it twice, so once over the first parallel line, then again over the next parallel line, the distance between the image or the very first image to the double prime image is going to be double the distance of the parallel lines. Okay, so if my parallel lines are 5 feet, then the distance from the initial point to the last point is going to be 10 feet. Likewise, if this distance right here is 10, the distance between the parallel lines is 5. So looking at that relationship and being able to problem solve those measurements. When you're reflecting intersecting lines, this is a little different. So you have your point of intersection. Okay, that's being shown right there. All right. The angle that is created is the angle from the initial to the ending. And again, you're reflecting it over the first intersecting line and then reflecting it over the next intersecting line. So the distance from the very beginning to the very end, that angle measurement is twice the measurement formed by the intersecting lines. All right, I'm going to repeat that again. The angle formed from the initial point to the terminal point, initial to terminal, that angle measurement is double the angle formed by the two intersecting lines. Right? All right, so copy and reflect. So if we're going to take this and we're going to do reflected in line P and then line Q. So when I look at this, it's going to be E, F, G, H. All those are prime. And then double prime is going to be H, G, F, and E double prime. Okay. So the single transformation would be a slide. It would just slide on down. And again, keeping in mind that the distance from H to H is going to be double this distance. Oh, I labeled these wrong. Silly me. Let's try this again. Did you notice that? Do you see my mistake? This should be H, this should be G, E, and F. And then this should be E, this should be F, this should be H, and this should be G. So the measurement from H to H is going to be double the distance between the two parallel lines. All right. So these are some things that you have for just kind of a concept summary. Glide reflection, a translation is a composition of two reflections in a parallel line, and a rotation is a composition of two reflections in an intersecting line. Interesting. So that's how they're all related. So sometimes you do your homework, just know that 17 through 20, you don't need to copy down, just describe the single transformation. All right. Have a great day. Bye. Oops, I tried to share my screen instead of stop recording. So now we're going to